go ahead and search something like regression models sklearn. Now, when I do that, I get this scikit-learn, which is the official documentation, and it says supervised learning. That is good. You want that. Click on it. Never mind, no information is available for this page. Why do I say that? Because boom, you can just click and switch to the stable version, and this is what you want. Regression and classification both fall under what's called supervised learning. This is when we know what the Y column is. Okay, and now you see underneath here some different options that you can use. So look under linear models. Okay, these are all different types of models. Now some are, it doesn't have it cleanly broken down to regression classification, but if you, let me just help you with this. Click on one of these like Ridge, okay? Now I'm gonna click on ones that I know about. Ridge, what is Ridge? You can see it uses an ordinary least squares, and it says it addresses some of the problems. Ridge actually has some regularization built in, so some of the preventing of overfitting. And you can see here, okay, I mean, you can click on it, might be the best thing. You know, let me click on Ridge in a new tab here. And here it is. It's an sklearn.linear model. And you can see there is this alpha, okay? And the alpha controls the regularization strength. Okay, it tells you can go from 0 to infinity. So this is an alternative to linear regression, which is what we started with. Okay, so we're just going to do like a little bit of a survey and try some different models. Okay, what we're going to do is go in depth with some particular models, but you can't go in depth about all of them. What you want to do is sort of have an idea of what a model is, and then you can just try it out and see how strong it is. Okay, so let's come back over here. Now, I said this is an alternative to linear regression. Let's just see how linear regression does with this. So from sklearn.linear model, I'm going to import linear regression, and then we'll do this model equals linear regression, and we can fit it and score it as such. Okay, now I'll just copy it in here. Okay, this looks good. Do note some students, common mistake. When you initialize a model, it's got to have parentheses. You're in effect like invoking the function. But when you get it from a library, you're not like running a function. It does not have parentheses. Okay, so how does regular linear regression do? Okay, 66%, not quite as good as the decision tree, but you know, decent, higher is better. Okay, so let's try Ridge now. Okay, we're gonna try some different models. Don't copy and paste. You see me doing it sometimes for speed. If you're gonna test multiple models, run a function. Okay, so let's make one DEF. Now you might want to do classifier, but for us, this is a regressor. And what we put in here is the model, right? And what do we do? Now it's interesting, if you put the model in here, I mean, I think you can just straight fit it. You can basically run these two. Okay, you fit it. I don't think you have to take the extra step to initialize it. It got to be tabbed in, right? You're fitting it and scoring it, and you can in effect return the score. Okay, let's see if this works just like this. Okay, so I'm going to try regressor, and what do I put in here? Well, let's just test one of these. If you got to import it first, but after you import it, then you can just put it in here as such, and then it sort of initializes, I think, inside, and you can see that works to get the score. So let's try Ridge now. From sklearn.linear model again. Okay, import Ridge. Now Ridge, I think it's just Ridge, right? You can do the classifier, I guess, separately. Yeah, just Ridge. And we're in regression, and now we can just try it. So let's see how it does. Okay, 0.687. And this is what happens in my experience. Ridge is sometimes a little better, but not much than linear regression. Now we could try to change that alpha. Double check the documentation, see alpha, and just see what some different values give us. It does say, it says don't use 0. It's just as it controls the strength. It doesn't tell us presumably higher is more control. Not clear from a quick scan of this, but let's just try with some different values and see. So what if we raise it to 2? Went down slightly, right? What if we change it to 0.5? Okay, I think it's pretty comparable. I'm not gonna like mess with the alpha, but that's what you would change, and that is ridge in a nutshell. So what else do we have in terms of linear models? Okay, we had ridge. I think I clicked ahead here. Let's go beyond the linear models. I see some of these and like I want to use them. We are going to go over k nearest neighbors. Let's go ahead and though and maybe put it in there first. Okay, so you can see there's a nearest neighbors regression. You click on it. It says k neighbors regressor, and you can get a sense of how it works from reading this. As mentioned too, you can click on these models here and get the official, like there it is. Okay, so here's how you read this. It's in the neighbors library. This is called a k-neighbors regressor, and you can choose the number of neighbors. Okay, what it does is, it's kind of cool. We'll talk more about this one in this series of videos here. It basically gives you the value of your closest neighbors. So if we come back to our data set here and we look at, you know, a new value, like let's pretend this last one's in the test data, we match it by its 5 nearest neighbors. And it's like, oh, if you look at the wind speed, et cetera, et cetera, et cetera, temperature, the weekend day, it's very similar to some other one, you know, and then what you do is you give the same value as that group. Okay, so it groups objects together. Again, we'll get more in depth in this, but let's just try it. So from sklearn.neighbors, okay, import k, was it k neighbors? There it is, k neighbors regressor. And now we can put it inside of our regressor. Okay, we'll just leave the default. And by the way, what this does here, just like the decision trees, it takes the mean value. Because if you're gonna like, see the in neighbors, in underscore neighbors, we'll leave the default of 5 in here, but I wanna put it up here. And neighbors equals 5. So in a classification scheme, it'd be like, oh, 3 of the 5 have a value of 0, so it's gonna be 0. But in this case, it's gonna be a range of values, so how do you pick among the 5? You don't, you take the mean. Same thing with the decision tree. When you have a decision tree and you ask it 4 questions, well, you end up with a lot of, you know, possibilities. So how do you pick what the value is? Right? If it was a classifier, hey, most of them are 1, you pick 1. Here, you take the mean value. Okay, so predictions often result in the means for regressors compared to classifiers. See how we do here? 72, okay, we're pretty respectable. So in between kind of the regressor and the and linear regression. Okay, let's do a couple more. So what else do we have within range? I mean, you could try any regressor. Okay, they're all done the same. That's kind of the point here. We could try something new. Bayes is often used for classification, I can tell you. Here's our decision tree regressor. Ensembling, which we're going to get more in depth in, you know, let's try a voting regressor. Okay. And oh boy, so it's going to combine different machine learning regressors. Let's see if we can just do this. This one may be more complicated. Yeah, you're gonna have to put in the estimators. We're not, let's come to ensembles at a later time, okay? But I actually like to click around sometimes in these and have, you know, different ones. Like AdaBoost is going to work, okay? So if we click on AdaBoost, okay, here's the AdaBoost regressor. This could be strong here. You can see estimator none. So let's just give it a try. This is a tree ensemble. Gradient boosting is something we'll get in depth with later. But while we're trying things out, you can try anything. This is my point. So from sklearn dot, is it under ensemble? Import AdaBoost. This was all the rage for a while, I can tell you. And then better boosters came out. We'll discuss in depth what boosters are toward the latter parts of these lectures. But let's just see for now, right? We're just testing different scores, different models. And let's see what we get here. 0.713, so did not actually outperform the k nearest neighbors or the decision tree, which is interesting. Very interesting, actually. Okay, so what else do we got? I mean, you got a lot. I would really encourage you to try a lot of them out. Because once you see how they work, they kind of just work. Multi-class is not what we're doing. That's special for classification. Yeah, like neural networks, there's a special way to do neural networks that it's covered in a future lecture series, but there is an sklearn way and you can try it. I don't know how strong it'll be, but you could just try it. It's a multi-layer perceptron regressor. Just give it a shot, right? So you can leave the defaults. Sklearn does have their own neural networks, but I am stating, okay, we do neural network. I do using Keras TensorFlow. Most people do, or using PyTorch. So these are just sort of like basic tests that you can try. Okay. So MLP regressor from sklearn neural network import MLP regressor, right? So you got to import it before you put it in the function. But note now we're no longer copying and pasting due to the function. So we're just putting it in here. Let's see what we get. Okay, it did not converge. And it's kind of amazing that this can happen where you can get like sort of an R squared that is like less than 0. It actually can work sometimes with the defaults, but you can see, maybe just from this one output, get an indication of why people may not prefer this as a method. So I would say experiment, have fun trying out different models. We will learn in depth about some of the stronger models or some of the more teachable ones. Naive Bayes is cool. I do want to just check. Where did that go? Do we have a regressor for Bayes? Seems like usually people come up with different ways of doing it. So how do we find out? Well, we can click on one. I don't know. Gaussian MB, it says for classification, right? So try those out for classification. And what we'll do next is look in depth at k nearest neighbors.